All right, so we just did our seafloor spreading simulation. So let's go ahead and go through the questions and key in our vocab. So the first question, magma is pushed up through the ridges in the seafloor to form new oceanic crust. Remember, magma is melted or molten rock material beneath Earth's surface. This cools to form rocks with larger crystals. So this is where a seafloor is created from. The energy from Earth's interior is transferred as the magma rises to cause the materials to move. So it's getting pushed up. The magma is welling. As each new layer emerges, the prior layer is pushed away from the ridge, so it's getting pushed up and out to create our seafloor. If the space between the boxes is the ridge and the craft sticks represent the magma, then which sticks would represent the oldest portion and which sticks would represent the youngest portion of the oceanic crust? Explain your answer using the numbers on the magma sticks. So looking at your pictures, when the magma is coming up and getting pushed out, what is older? Are the ones on the outer edge towards the trenches older, or the ones coming right out from the ocean crust older? Remember, this is happening at a mid-ocean ridge, an underwater mountain system formed by plate tectonics. It's the largest single volcanic feature of Earth. So what's happening? Which sticks are older, the ones on the outside or the ones coming up from the mid-ocean ridge? So the addition, number 2, the addition of new oceanic crust is one mechanism that applies force to tectonic plates. The model did not accurately show the direction of force during the creation of new crust. Remember, crust is the thin, solid, outermost layer of Earth, is either continental or oceanic, okay? So crust is the outermost layer of Earth, and we're talking about oceanic crust. So when we are showing our motion, we're pulling the popsicle sticks, but we know that that's not really what's happening. The magma is welling and being pushed out. So, how could you change the model to show that magma is pushed out at the ridge? So what could you do? Get creative. Number 3, compare the pattern of red basalt and the white basalt on either side of the ridge. What do you notice? So when you are looking at the white and the red popsicle sticks that are coming out from the mid-ocean ridge, is one going faster than the other? Is one going slower than the other? Or are they coming up at the same time? Look at the video and notice the numbers on the popsicle sticks. Are they equal, or is one significantly faster or slower than the other? Okay? So, number 4, what forms as the new rock material continues to move away from the ridge? So we talked about this a little in the video. When the magma is being pushed up and then out, the ocean basin is being formed. So hint, hint, we're giving you the answer to number 4. Ocean basin is the depression of Earth's surface in which an ocean lies. Okay, so it's the basin of the ocean. This is the ocean floor, the sea floor. Number 5, what will happen to the oceanic crust that is pushed down at the trench? Is crust formed, or are we recycling at trenches? So when we were at the trench, it is a deep and narrow depression in the seafloor where the subducted plate moves into the asthenosphere. So here's our trench. Here's our 2 tectonic plates moving in, and one is going under the other one. So when the magma, or when the ocean floor goes back into the trench and goes all the way down to the bottom, back into the core, what is happening to that magma? Is it getting recycled, or what's happening? Number 6, the geological process is the recycling of the ocean basins. As new crust is formed at the ridge, a process called subduction occurs at the trenches. Why must subduction occur at the trenches? So what this question is asking is, when we have 2 tectonic plates moving towards each other, which creates that trench, why does one have to go underneath the other? Why can't they come in towards each other and then just keep spreading? What would happen if we didn't have one go under the other? Would we have a bigger ocean floor? Does our Earth give us enough room to make more ocean floor? Or does it have to be pushed underneath each other because there's no room? Think about it. So, how does the seafloor spreading provide evidence of past plate motion? Okay, so we need to think about that and answer that question.